Okay, so you've tried negative fraction exponents. We want to put all our fraction rules together now. So we want to use our multiplication rule, our division rule, our power to power rule. We want to use all those rules with any kind of exponent, including our fraction exponent. So remember that when you see the word simplify, that means to use your exponent rules and write a single power. When you see the word evaluate, it means that you're going to actually get an answer. Apply the exponent. So, example, simplify first, then evaluate the following. Same rules apply here as we talked about before. Use multiplication, division, power rule first. Deal with negative exponents always last. When we're dealing with fractions, you want to always leave your answer in lowest terms. And do not use decimals in your answer. So when I look at A, I have the same base and it's a multiplication question. So if I'm multiplying with the same base, I'm going to keep my base and I'm going to add my exponents. So I have 3 over 5 plus 7 over 5. The difficulty becomes remembering how to add fractions. When you add fractions, you keep the denominator the same and you add the numerators. So 7 plus 3 would give me 10 over 5. And if you're following along, 10 over 5 is like 10 divided by 5. So I'd have an exponent of 2, which means I would have an answer of 25. So when you use your exponent laws, often the fraction exponents work their way out, and it works out nicely for you. If I look at B, B is a dividing question with the same base. So I keep my base and I subtract my exponents. So I have 3 over 4, take away negative 9 over 4. Be careful with your signs. We've learned this from doing our exponent questions before. If I take away a negative, it's like adding. It's like plus 9. So I keep the denominator of 4, and 3 plus 9 is 12. And 12 over 4 is like 12 divided by 4, which is 3. So I have 8 to the exponent 3. You get your calculator out. 8 to the exponent 3 is 512. All right, next question. So when I look at the next question, I've got one base and 2 exponents. That means I would use the power rule. So as usual, I keep the base and I'm going to multiply my exponents together. So I have a quarter times 8 over 3. To multiply your exponents, you multiply the numerators together and you multiply the denominators together. So you would have 1 times 8 is 8 and 4 times 3 is 12. And when you're working with fractions, you always want to leave your fractions in lowest terms. So I look at those numbers and I want to make sure there's nothing they both divide by. In this case, both of them divide by 4. So I'm going to reduce them. 8 divided by 4 is 2 and 12 divided by 4 is 3. And we've been learning what to do when we have a fraction exponent. So I got to keep going. That means the bottom number is the root and the top number is the exponent. So the cube root of 8 is 2 to the exponent 2, and our final answer is 4. So D is the same idea. One base, 2 exponents. We're going to do the power rule. We're going to multiply a half times negative 4 over 3. So we multiply the numerators together and the denominators together. Keep my base. So 1 times negative 4 is negative 4, and 2 times 3 is 6. Just like the last one, I want to reduce my fraction. I know both of those are even numbers, so they're both going to divide by 2. So if I divide them both by 2, I have negative 2 over 3, which is another fraction exponent that's negative. That's okay. A negative exponent just means you put 1 over, keep your base, the bottom number is the root, the top number is the exponent. So I keep my fraction, The cube root of 27 is 3, and the exponent is 2. So I have 1 over 9. You may need to pause and go back and replay the video and get your examples down. I will let you guys work that out. Once you've got all the examples down, question number 4 from that same handout we've been working on is what you need to finish up with.